the problem-solving strategy, and this is associated with the equation y equals a function of x. This means that the process output depends on a function and on the process input or inputs. Okay, so in the figure that we have in front of us, this is a typical image of a process. We have the process inputs represented by the letter X. We have the procedure, which is the process steps between process start and process end. These are also represented with the letter X. And finally, we have the output or outputs, plural, represented by the letter Y. So this is the so-called problem-solving strategy, or the power transfer equation. A causal theory is about you create an output from an input and a function. So the input is X and the function is F. Looking at inputs and outputs, we see that they come under different terms. So inputs are represented by X, and we have important inputs, and these are represented by capital X, and less important inputs that are represented with a lowercase x. So inputs are x1, x2, x3, xn. They're also known as independent variables because we can set them up at specific levels and we can control the inputs. For example, if you talk about a particular drug, you can administer it at 10 milligrams, 20 milligrams, 30 milligrams, etc. So you can control the dosage. That's why they're called independent variables. They're also known as causes, like cause and effect. So every time that we're talking about root cause analysis and identifying the root causes, we try to find out which are the inputs that have a significant impact in the outputs that is associated with the business problem that we try to solve. And finally, the process inputs can be controlled. Speaking about the process outputs, again, we have significant or critical process outputs, and these are represented by the uppercase Y. And we have less significant ones, and these are represented by the lowercase y. Process outputs come under different terms. We can call them outputs. These are dependent variables, which means that the output depends on the process inputs. It is known as an effect, like cause and effect, and we can monitor, we can measure, but we cannot control the process outputs. We can have an explanation about, the three letters associated with the problem-solving strategy. So Y is what you get out of a process. We call it the process output. X is what you put into the process. We call it process input. And finally, F is what you do in order to transform an X into a Y. And this is the function. So if we use manufacturing terms, the output is typical a physical product. For example, a desk, a table, a TV. X is what we put in the process, and this can be, again, in a manufacturing environment, typically parts or raw materials. And finally, speaking about the function. In manufacturing, this is machining and processing of the inputs in order to have a finished product. So, whenever we have a problem with the process outputs, for example, if the process outputs indicate signs of excess variation that is outside of the customer specification limits, then we have to look at two potential sources of the problem: an input and the procedure, which is the function. These two potential sources of a problem are not mutually exclusive. You could have an issue with both your inputs and your outputs, or with one of them. Now, most processes are very complex. In other words, they comprise of multiple steps. For example, between the process start and the process end, we may have 10 steps that they have to be completed in order to have the final process output. This is why we have to prioritize the process outputs. And as I mentioned earlier, with capital Y, we represent the critical process outputs that are very important to the customer. And with lowercase y, we represent all the other process outputs. So problems in a sub-process, they can be replicated and they can be enlarged as its input moves through subsequent sub-processes or process steps between the starts and the end of the process. On the figure, we can see that we can have multiple process outputs, we can have multiple process inputs, and there's always a margin of error associated with each combination of input and output. When you have a problem with the process outputs, the causal theory tells us that there are typically two culprits that we have to take into consideration. The F, the function, your procedure for creating that specific output, and also the X, the materials or information that you're adding to that procedure. So, using the transfer function equation, y equals a function of x, you can help determine the cause and effect relationship in a process improvement project. And this can be used in order to measure performance and determine areas of potential process improvement. So in Six Sigma, this formula is considered to be the so-called breakthrough equation. Now, looking at the two figures, the left, we have the breakthrough equation, the outcome, y equals the function, and the associated input. And on the right-hand side, it is the same breakthrough equation with a little bit more detail about the elements of the equation. So, in real life, processes are complex. They do not comprise of one step, they comprise of a series of successive steps that they have to be completed in order to have a desirable effect, which is the process output. In other words, expanding on the power equation, the total output from a process is the total sum of the uppercase and lowercase y's, y1 plus y2 plus y3 plus yn. So your total output from a process is the sum of the outputs from each of the sub-processes or process steps. Now, if you have issues with your outputs in the context of a complex process, then a good starting point is to break down the process into sub-process or individual steps that have to be completed in a specific order. And you have to look at the output from each of the sub-process. And the figure that we have illustrates the concepts that I just described.